Hello everyone, and thank you for joining us for this installment of our Tech Tuesday series. Today we're going to be exploring 3D printing from a slightly different perspective than you might be used to. But first, I want to give you just a quick background on me and CAMLogic. CAMLogic has been around for the better part of 2 decades, and if you can't tell by the name, we started in the CAM industry. We've now expanded into many other facets of engineering and production, including 3D scanning, CAD, CAE, and 3D printing. And because we started toward the end of the production process and worked our way to the beginning, we have the fundamental understanding of what has to be done to assure that each step of the process will result in a product that will actually work into the next phase of development. And so this is what CAMLogic is really all about. We're a Siemens PLM partner, so we offer training and support for NX, NX CAM, Solid Edge, Team Center, etc. We also have a staff dedicated to 3D scanning and, of course, 3D printing. And because we have engineers, sales, and support staff dedicated to these 3 facets of engineering, we have the knowledge and, I think perhaps more importantly, the experience to show you how to tie all these tools together so that you can be better designers and engineers. So I really like to think of CAMLogic as the glue that ties these bodies of knowledge together into one amazing resource for designers and engineers. And as for me, I manage our engineering efforts on the 3D printing and 3D scanning side of the business. Before working at CAMLogic, I worked in the enterprise IT field as a system administrator. And before that, I owned my own company that specialized in custom home theaters, media distribution, and small business IT. So that's just a quick background for a little bit of context for today's discussion. So let's move on to today's topic. Now, if you just need a few one-off parts or you're looking to mock up a prototype design, most people today are turning to 3D printing. It makes sense because after all, prototyping is what 3D printing was invented for in the first place. And up until recently, the process was really only known as rapid prototyping. But of course, now we have the term 3D printing. And with 3D printing, we've seen amazing things happen in the automotive industry and the aerospace industry, consumer goods, and of course, the healthcare and medical industry. So 3D printing is obviously the future of making things, right? The holy grail of manufacturing and the key to the democratization of design. Well, sort of. I think it's safe to say that by now, most of us feel maybe a little bit let down by 3D printing. There was a lot of hype around the promise of this seemingly new, exciting technology. But many of these hyped up expectations haven't quite been met. You still have to spend a lot of money to get even a decent printer, and even then, print jobs may not turn out how you intended. And that's assuming that the print job finished at all. Often the software isn't intuitive, and printing anything other than a little miniature Yoda head can be pretty challenging. So, okay, 3D printing's 15 minutes of fame are up. And that's okay. That doesn't mean that 3D printing is going the way of the dodo. Believe me, this technology is going to be around for a long time. In fact, 3D printing, or perhaps more correctly, additive manufacturing, is still being touted as a game changer in the manufacturing arena. So what's wrong with additive manufacturing? What's keeping it from living up to the promises that we were given? What is the 3D printing industry doing wrong? Well, certainly part of it is the maturity of the technology. Between the mechanical, electrical, and chemical engineering that goes into developing these technologies, there's an immense amount of complexity and myriad challenges to overcome. These are technical challenges, so they're being solved, and eventually the machines will be as reliable as the laser printer in your office. And someday in the future, we'll just hit Control P, and the thing that we want will just print in our office 3D printer. So I wouldn't worry too much about the technology living up to its potential. But I think that there's actually a non-technical issue that is even bigger that needs to be addressed. And it's the first of two main points that I want to concentrate on today. So what is this issue that still needs to be addressed? That's it. That's right, folks. You as the designer, the engineer, are not using the technology properly. Many of us are not yet looking at design from the perspective that anything, no matter how intricate or complex, is manufacturable with additive manufacturing. And I'm not the first one to present this idea. Jeff Kowalski, the CTO of Autodesk, has talked and written about this. And Mark Little, the CTO of GE, who is investing tens of millions of dollars into their additive manufacturing capabilities, says that his engineers can, quote unquote, make parts in a way that we simply couldn't make them before. So I'm not offering a completely novel idea here, but I think that it's important to continually help engineers and designers understand that this technology, additive manufacturing, allows us to fundamentally change the way that we design. So let's go ahead and take a closer look at this idea. Now, we were told that 3D printing would revolutionize the manufacturing industry and that the old ways of making things would be obsolete. So things like the stamping press for sheet metal, the injection molding machine for plastics, and even CNC machining with all of its capabilities was supposed to be a thing of the past. And so when 3D printing started making waves in the media, everyone said, great, let's just start 3D printing these sheet metal parts that we've been making on the stamping presses. Let's see if we can just 3D print these plastic parts instead of injection molding them. And maybe instead of machining these things with a CNC, we can just 3D print them. Well, here's the problem. These things are already being made with the standard manufacturing processes. There's no reason to make them with an additive manufacturing process. Frankly, there's nothing that special about them. And in almost every case with today's additive manufacturing technology, you're not going to save any money by 3D printing them. And most of the time, you're not going to save any time either. So maybe let's look at an example that does illustrate the power of additive manufacturing. Ladies and gentlemen, I would like to present to you the bracket. Now, when engineers talk about brackets, really just about anything can be called a bracket. If there's a part that is so generic that it doesn't even deserve a name of its own, its name becomes bracket. It's just a piece that attaches something to something else. Even the more complex brackets of the world, like the ones on the right, aren't going to get so much as a shoulder shrug from engineers. So the homely bracket is about as utilitarian and uninspiring an object as you could possibly imagine. Until you see a bracket that looks like this. This is also a bracket. It's a sensor bracket for a satellite designed by LKE in the Czech Republic. We can clearly see what they've done with the design. We have the complicated lattice structure that makes up the legs, and the more bulky areas at the top and bottom are needed only for attachment. The folks that designed this knew that because the part was going to be additively manufactured, there were no constraints on their design. And because they were able to design such a complex and open structure, they were able to achieve more than 25% reduction in weight compared to the original design. And of course, all while maintaining the structural integrity of the part. And again, this design is only possible with additive manufacturing in mind. And this is another bracket. It's a design from Airbus, one of the world's leading aircraft makers. As you might imagine, weight reduction is sort of a big deal when you're in the business of keeping giant metal tubes hurtling through the skies at over 500 miles an hour. Strength also is fairly important. This bracket was also redesigned with the assumption that additive manufacturing would produce the final end-use part. The design could be intricate and organic and complicated without any concerns about whether the thing could actually be made. The ability to reduce component weight by 30 to 55% while reducing waste by up to 90% is a real game changer in the aerospace industry. Airbus is really leading the way, and they're going to get there by using additive manufacturing. So again, the idea is not to see if we can 3D print the same thing we're already making. The idea is to reinvent the thing, because even something as bland and boring as a bracket can be reimagined as something beautiful and inspiring. So that's the first idea that I wanted to share with you today about 3D printing. And this is the second. So as I mentioned, we've all been led to believe that additive manufacturing will forever change the landscape of manufacturing and revolutionize every industry from food to fighter jets. But 3D printing will not change the world. We, as humans, will change the world, and 3D printers will help us get there. Now, don't get me wrong, I'm not saying that 3D printing will not profoundly change the manufacturing industry, because I believe that it truly will. What I'm saying is that inventions like electricity, in and of itself, change the world. Wireless communication, in and of itself, changed the world. But 3D printers are really just tools. They are things that make other things. And by themselves, they really aren't terribly useful at all. And in that regard, they aren't that different than the stamping press. But, just like any other tool, in the hands of a talented and motivated person, 3D printers can help change the world. So our Earth is 70% water, over 330 million cubic miles. But only 2.5% of it is drinkable. That little sliver right there. And of that 2.5% of fresh drinkable water, only 0.3% of that little slice is in liquid form on the surface of the Earth. So with 7 billion people living on Earth today, if we take that 0.3 of the 2.5% and do the math, it comes out to around 4 gallons of water per person for a lifetime. Even if you divide out the entire 2.5% of fresh water on and in the Earth, it comes out to about 1,300 gallons per person for your entire lifetime. Which, when you consider that the average U.S. household uses around 300 gallons per day, the math just doesn't really add up. There's not enough water to go around. So it's no surprise, unfortunately, that current reports show between 1.2 and 1.5 billion people suffer from drinking water shortages. So at the conservative end, that's 1 out of every 6 man, woman, and child that doesn't have access to clean water. That's a pretty serious problem. Now, there are many regions affected by water scarcity, including right here in the US. Water scarcity has many causes, including groundwater overdrafting, lack of proper sanitation, which leads to water contamination, and regional conflicts. And of course, these many causes have many possible solutions. Some of the hard-hit areas would benefit from economic aid. Others may simply need a good, steady rain after a record drought. But there's one obvious idea that's actually been around for thousands of years. Desalination. Taking the usually undrinkable water from the oceans, removing the salt, and leaving potable water fit for human consumption. And it's already being done today all over the world in plants like this one in Spain. There are a number of different technologies employed to achieve desalination, and some of them have been around since the beginning. Distillation, which is still widely used today, was used by the ancient Greek sailors to evaporate water away from the salt, and the Romans used clay filters to filter the salt out of the seawater. But here's the problem with today's systems. As you can see in the photo, they're huge, and the facilities that house them are huge. They're complicated, they're expensive, and they take a long time to bring online. And that's where 3D printing comes in, and these guys. This is Doug Hofer, a steam turbine specialist at GE, and Vitaly Glisiansky, a chemical engineer at GE. And what they're holding is a 3D printed turbine that can make desalination more energy efficient and cost effective. As you might imagine, the water cooler talks at GE's Global Research Center can get a bit technical. And when Doug and Vitaly ran into each other, they thought that maybe they could use the steam turbines typically used in power plants to help solve some of the issues with desalination. So what they did is they miniaturized their turbine design and 3D printed a working system that fits in the palm of your hand. This new design compresses and streams a mixture of air and salt water through a cooling loop that freezes the water and separates it from the salt. The ice is then left to melt into drinkable water. It's a beautifully elegant system that could reduce the cost of desalination by 20%. Not to mention how much smaller and simpler the entire design is, which will only help to increase adoption. So the hope is that with an easier, less expensive approach to desalination, maybe 1/6 of our world's population won't have to struggle to find our most basic and necessary compound. So yes, technology can help us solve some of the greatest problems facing the world today. But technology will not actually come up with the solution. That's up to us.